The principle of the motor that you didn't understand is really simple. If your physics teacher taught you this way back then, you would have been admitted to Tsinghua University. This is a magnet. It has north and south poles. If you bring another magnet over and put them together, you will find that they attract each other, and the same poles repel. And whether you use it or not, this magnetism will always be there. This kind of magnet that can't be turned off is called a permanent magnet. Now we make a hole in the permanent magnet and put an axis through it so that it can rotate freely. Then bring another magnet closer to it. You will see a very interesting phenomenon. The magnet in the middle will rotate by itself until one pole faces the other. Next, we replace the permanent magnet with a metal bolt. The bolt itself is not magnetic. No matter how close you get to the magnet, it won't move. Now we wind a few wires around the bolt and connect it to a battery. When the current passes, the originally messy magnetic domains inside the bolt are forcibly aligned by the current. It immediately becomes a magnet. This kind of magnet made temporarily by current is called, and it is much smarter than permanent magnets. As long as you turn the battery over and the direction of the current changes, the poles are immediately reversed. The original north pole becomes south pole, and the S pole becomes the N pole. Without flipping the battery or change the wires, the effect is the same. Now replace the permanent magnet that can rotate and replace it with this electromagnet. When it's electrified, it immediately rearranges with the magnet. When the current is reversed, the poles are immediately reversed. Like poles repel. Like poles repel, it will be pushed by the magnetic field to continue to rotate. If you keep switching the direction of the current, it can keep rotating. To make it rotate more powerfully, we add a permanent magnet on the other side. Both sides push it, and the power doubles directly. This is the most basic motion of an electric motor principle, but the problem is, you can't sit there and manually change the wires. So engineers came up with a very clever solution. On the winding structure in the middle, they added a commutator. It's a metal ring with a gap in the middle, which rotates with the rotor. Bushings are installed on both sides. Current enters the coil through the brush. When the rotor turns halfway, the brush will automatically change sides, and the direction of the current will automatically reverse. The poles of the electromagnet will instantly reverse. The magnetic field continues to push. The rotor can keep rotating. It doesn't need any human management. To make it rotate more stably, we can add many more coils. They are turned on in turn, so no matter which angle it turns to, there is always a magnetic field pushing it. The more coils, the stronger the magnetic force. The greater the torque of the motor, the faster it rotates. This is why when you open a motor, there are densely packed copper wires inside. In life, you see children's toys, electric fans, electric toothbrushes are basically based on this principle. And AC motors are even smarter. It doesn't need a commutator or brush. It mainly has two parts. The outer part is called the stator, and the rotating one is called rotor. Instead of a single wire, but 3 sets of coils. And these 3 sets of coils are just staggered by 120 degrees. When you pass 3-phase alternating current into it, the magnetic poles of these 3 sets of coils will change. This one just becomes N pole. The next one becomes the S pole. And the next one starts to switch. From the outside, it's like an invisible magnet is rotating. This is called a rotating magnetic field. Now let's focus on the middle. In the middle of the stator there is a metal rotor. It is not connected to electricity, nor a magnet. It doesn't seem to do anything. But the rotating magnetic field outside keeps sweeping it. When the magnetic field changes, according to the law of electromagnetic induction, a current is induced inside the rotor. Once there is current, the rotor immediately acquires magnetism. At this time, the external magnetic field is rotating. The magnet inside wants to chase it, so the rotor starts to rotate. This is why it is called an induction motor. The current is not connected, but is induced. Can't the rotor catch up with the magnetic field? If the rotor really catches up with the magnetic field, the magnetic field will no longer cut the rotor. The induced current will disappear immediately. The magnetic force is gone. The rotor will slow down, so the magnetic field starts cutting again. Current appears again. The rotor is pulled to accelerate again. There is always a little speed difference. This little difference is called slip. It is because of the slip that induction motors can rotate stably. The speed of the rotating magnetic field is only determined by the frequency of the input power. So as long as you use a frequency converter to adjust the frequency, you can easily control the motor speed. This is why induction motors can be used in electric vehicles.